class, but today we'll be handling a very simple topic in chemistry that most of us know, types of chemical reaction. But before we proceed, what do you understand by the term chemical reaction? Okay? Chemical reaction, what is a chemical reaction? If you have been asked as a science student, what is a chemical reaction? A chemical reaction is simply an interaction between atoms of elements to give rise to what? New products or new atoms. Okay? So chemical reactions are represented with a chemical what? Equation. So a chemical equation is a representation of what? Reactions. And it's composed of reactants and the product and a reactant part, or the arrow indicating the direction of a reaction. The direction could be a reversible reaction, it could be an irreversible reaction. So generally, chemical reactions are very, very important in chemistry. And you can be asked, what are the proofs that shows that a chemical reaction has taken place? There are about 4 proofs you need to know. The first one is definitely there will be evolution of gases. If gases are given out in a reaction, it means that the reaction is successful, right? Another one is temperature change. If there's a change in temperature, for example, before the reaction, the container was cooled. After the reaction, the container becomes hot. It means that heat has been given off, right? Also, in some reaction, heat is also absorbed. So evolution of gas, which is the number 1, and number 2 is what? Temperature what? Change. Another factor, another thing that will indicate that a reaction has taken place is the color change. In your titration, whenever you do titration in school, you notice that whenever a reaction attains endpoint, the color will change from either colorless to pink or from orange to whatever. It will change the color, indicating that the reaction is complete. And lastly, the 4th evidence that shows that a reaction has taken place is precipitation. Okay? In some reactions or some of your analysis you do in your lab, we call it qualitative analysis. In some of analysis you do in your lab, you notice that precipitates are either formed at the top layer of the what? The test tube. Some of them can be white, some can be greenish, some can be what? Yellowish, depending on the reaction you're doing. So the formation of a precipitate indicates that this reaction has taken place. So altogether, I have given you 4 proofs that shows that a reaction has taken place. Color change, evolution of gas, temperature change, and precipitation of solids or liquids, depending on the reaction you are performing. So today, we'll be looking at types of reaction. There are several reactions in chemistry, but we are going to narrow this class to about up to 5 to 6 reactions that will help you understand that yes, this reaction is addition reaction, this reaction is decomposition, this reaction is displacement, this reaction is precipitation, this reaction is double displacement. How will you know a reaction is combustion? How will you know a reaction is neutralization reaction? All these things, you need to understand them one by one. So the first reaction we'll look at is addition reaction, or you can call it synthesis, okay? Addition, or you can call it synthesis. Synthesis. Just like the name implies, addition reaction simply means when you combine 2 or more elements to get a single product or a single compound. Example, if I have A plus B to give me just C, this is a synthesis reaction. I combine A plus B to give us C. 2 things combining to give us 1 thing. It must not be only 2 things. I can also have A plus B plus C to give us D. Okay? The end point is that 2 or more elements or compounds or molecules are combining to form a single product. Example, synthesis of ammonia. For example, nitrogen reacts with hydrogen to produce ammonia. This reaction is a synthesis reaction. We are producing ammonia from the reaction between nitrogen and hydrogen to produce ammonia. Okay? With the presence of what? A catalyst. So catalyst is present, right? So this reaction is a synthesis reaction. There are numerous examples. When you visit the app, you will see a lot of examples that can back up each of these reactions we are doing. But this is just a simple reaction that shows us a synthesis or addition reaction. Number 2 reaction is decomposition reaction. Please note that decomposition is the opposite of synthesis. Decomposition is the opposite of synthesis. Let me show you what I mean. Remember that in decomposition, A plus B gave us C, but now watch, in decomposition, C will decompose to give us A plus B, opposite. Now this decomposition can be brought about by either heat or catalyst. If it is heat, it's called thermal decomposition. If it is heat that brought about this breaking to give us these two, it's called thermal decomposition. If it is catalyst, it's called catalytic decomposition. So whether it's a heat or a catalyst, the end point is that C is decomposing to give us A and B. Example is calcium triiosocarbonate 4. This compound will decompose by heat, okay, to produce calcium oxide plus CO2. This gas will be what? Given off, indicating that the reaction has taken place. So such decomposition by heat to produce calcium oxide and CO2 gas is called thermal decomposition. It's called thermal decomposition. A good example again is potassium triiosochlorate 5. If you decompose this by heat also in the presence of a catalyst, you have KCl plus oxygen. So the equation is not balanced. To balance it, I'll put 2 here, put 2 here, and then put 3 here. It's balanced. The first one is balanced without touching it. Okay? So this equation shows that these compounds are decomposing to produce 2 or more products. The opposite of what? Synthesis. Synthesis, building up. Decomposition, breaking down. The opposite of the reaction of the first one is this one we are doing here. So this shows a simple decomposition reaction by heat and catalyst to produce their products. Now, number 3 reaction, the third reaction is single displacement reaction. Single displacement reaction. Single. Why do we say it is single displacement? Look at what is meant by single displacement. Look at A. Let's use letters to represent this. AB reacting with C. What happened here? What did you see that happened here? C displaced B. Sent it out. So that A and C will combine to give you AC plus B. This B has been displaced. That's why it's called displacement. And why is it single? It's single because just one parameter was displaced. Okay, look at the second one too. It's still displacement reaction. C displaced A to react with B to form BC. A is displaced. Notice that in the first one, B is displaced. Second one, A is displaced. Now, under single displacement, we have cationic displacement and anionic displacement. Now the question is, which one is cationic, which one is anionic? Remember that if I am to split these two things together, if I should split them, the first one is always positively charged, second one is negatively charged. The positive charge comes first, negative charge comes second. If you displace the first one, if it is okay, for example, what was displaced in this first one is the B. Since B is displaced, this one is an anionic displacement. Okay? But since A is displaced here, A was displaced here, and A is the cation, so we call this one cationic displacement. So cationic single displacement means displacing the cation from the compound, while anionic means displacing the anion from the compound. And since we are displacing just one of them each, it's called single displacement reaction. Example, look at this reaction. Zinc reacting with HCl. In this reaction, and also take note, this displacement can only happen if the one coming to displace what is already here is more reactive or is higher than that one in the electrochemical series. For example, zinc is higher than hydrogen in the electrochemical series. Zinc is more reactive than hydrogen. So zinc can easily displace hydrogen, which is the cation here, to form zinc chloride plus hydrogen gas. Hydrogen gas will be given off. So balancing the equation, we have to put 2 here and that is it. Okay, so in this reaction, this kind of reaction is a single displacement cationic reaction, because hydrogen here is the cation. So displacing hydrogen to form zinc chloride and hydrogen gas indicates that the reaction is a single displacement cationic reaction. So this is a good example about this single displacement reaction. There are more examples. Check in the app, you see more examples on this. You understand what it is properly. Now the next reaction is double displacement reaction. Okay, this is quite easy. The reaction is simple. What's happening here is changing of what? Of the ions, right? So remember that if I'm to have this to be positively charged, negatively charged, positively charged, negatively charged, of course the positive charge will go with this to form AD. The positive charge, the elements that are positively charged are written first, right? While the second one will give me C and B to give me CB, right? So this kind of displacement, A displaced C and C displaced B. Okay, so this displacement reaction here is a double displacement. Let me explain again. In this displacement, A went with D and displaced C, while C came here and went with B and displaced A. So what is happening here is a simultaneous displacement reaction that leads to the formation of a product. So let's give example using equations. Okay, let's not use letters. How do we do this? Okay, example, we can have so an example of this reaction is barium chloride reacting with sodium sulfate. Okay, this is a displacement reaction. Okay, barium will displace sodium to react with barium sulfate to form barium sulfate, while sodium will go with chlorine to form sodium chloride. Okay, so we are going to also discuss this double displacement reaction. Could either be precipitation reaction or it could also be a neutralization reaction. So, but I'm just trying to explain what is meant by double displacement. Okay, barium displaced sodium to work with barium sulfate, while sodium displaced barium to work with what? Chlorine to form sodium chloride. So balancing the equation, we could have 2 here, and then I think the equation is balanced the way it is, right? So there are more examples on this. Also, this is also a displacement reaction. This is also a displacement reaction. Reacting this with sodium hydroxide is also a displacement reaction. Okay, hydrogen here will displace OH, sodium to form water, while NO3 will react with sodium and displace OH. So we have sodium nitrate plus water. Okay, balancing the equation, you have, okay, it's already balanced without balancing it, right? Hydrogen is 2, hydrogen is 2 there, nitrogen is 1, oxygen is 3, it is 3 plus 1, 4, so 4 here, sodium is 1, sodium is 1. So this equation are examples of a double displacement reaction. But inside this double displacement reaction, we also have precipitation, right? Precipitation follows this reaction, and also neutralization reaction follows this reaction too. So the next reaction we're going to talk about now is precipitation reaction and neutralization reaction as a double displacement reaction. Now, for a precipitation reaction, it is a double displacement reaction most times, not all. Some can be single displacement too. But what makes it a precipitation reaction is because of the fact that when you react 2 insoluble substances together, or when you react 2 substances together, it forms an insoluble part. The solution forms an insoluble part which separates from the solution and forms at the outer layer of the solution. So such a clear difference between that solution and the one inside indicates that a precipitate has been formed. Let me give you an example. If I have, let's say, a test tube, and inside this test tube I reacted A plus B, and the moment I reacted these 2 things together, I noticed that there is a kind of a gelatinous substance that will be formed at the super layer, at the upper layer of this solution. So that's precipitate that has been formed here indicates that the reaction is a precipitation reaction, because a precipitate will be formed, differentiating itself from the solution. So such precipitate could be colorless, it could be green, it could be yellow, it could be any color. What matters is that it is going to separate itself from the solution. So such a reaction is called precipitation reaction. So most times elements that can precipitate are silver, barium, depending, but these two elements I mentioned now are the core elements that, and also lead. Okay, they can precipitate. All right, so let's look at the equation of a precipitation reaction. Let's quickly look at an equation that explains precipitation reaction. A good example is reaction of magnesium chloride. Magnesium chloride plus silver nitrate. So this reaction is going to follow a double displacement reaction. Okay, but the end point is that a precipitate will be formed. So what is the precipitate? Look at the reaction. A reaction between these two will give us silver chloride. Silver chloride plus magnesium nitrate. So balancing the equation, remember how did the reaction go? Silver will go with chlorine, then NO3 will go with magnesium, right? So have magnesium nitrate. So the precipitate is this. So how do we show a precipitate? We use an arrow. An arrow pointing down indicates that this is the precipitate. Okay? This is what is precipitated at that upper layer of that test tube. So balancing the equation, we put 2 in front of here to balance the equation. Then probably put 2 here too to balance this guy, and then it's balanced, right? So this equation shows that the reaction is a precipitation reaction. Another example of such reaction is reaction of barium chloride and sodium sulfate. Example is reaction of barium chloride and what? Sodium sulfate. This reaction is a precipitation reaction because a precipitate will be formed. And the precipitate is what? Barium sulfate. Barium will go with sulfate here to form barium sulfate, right? Plus, then sodium will go with chlorate to form sodium chloride. So balancing the equation, we have 2 here. So we put an arrow indicating that a precipitate is formed, which is barium sulfate. Is it balanced? Yes. Barium, barium. Chlorine, 2 atoms, 2 atoms. Balanced. So this reaction is a precipitation reaction. How do we know it in a reaction? Just the arrow. The arrow sign will tell you if a reaction is precipitation. Once you have seen this arrow towards a reactant or product, it shows that the reaction is a precipitation reaction. The next reaction we'll talk about today is neutralization reaction. Okay? In this reaction, it is actually a reaction between an acid and a base, or most times we call it alkali. Okay, alkalis are called soluble bases. Okay, they are bases that can dissolve in water. Simple, they are soluble base. So when you react an acid and an alkali, the reaction produces salt and water, except for carbonates. Carbonates react with acids to produce salt, water, and CO2. Okay, example of what I'm trying to say is this. If you react HCl with sodium hydroxide, a base, this reaction is a double displacement reaction, right? Hydrogen will displace sodium here to react with oxygen. So what I'll have here is sodium chloride, which is a salt, plus water, right? The equation is balanced without touching it. Check it is balanced. So this is an example of what? A neutralization reaction. An acid and a base gives you salt and water. So this is the acid, this is the acid, this is the base, this is the salt, this is the water. Okay? Another example is reaction between H2SO4 plus potassium hydroxide. It's also a base. So react with this, the same thing will happen. What I'll have here is potassium sulfate plus water. Balance the equation, we place 2 here to balance the potassium, making it 2. Oxygen is already balanced, 2 plus 4 is 6, 2 plus 4 is not balanced. I'll put 2 here to balance the oxygen and the hydrogen. Hydrogen is 2 plus 2 here is 4. Okay? Another example is reaction of HNO3 plus, let's use another bit, let's say calcium hydroxide. Calcium hydroxide. Okay? Can it work? Yes. So in this reaction, you are reacting calcium hydroxide and HNO3. Right? So from this reaction, we can see that calcium will react with the NO3 to form the salt, calcium nitrate, right? Plus water. Is it balanced? No, it's not balanced. To balance it, I'll put 2 in front of here to balance the hydrogen and the nitrate ion. So the next thing is to check the other element. Calcium is 1, calcium is 1. It's balanced. So the nitrates are balanced and the hydrogen is also balanced. So this is the balanced equation. Okay? Now, notice that all these reactions are forming salt and water. But there is a reaction which is also this reaction. But the difference is that it will form CO2. That is when a carbonate is involved. Example, if I'm reacting HCl plus sodium triazocarbonate 4, okay? If you react it with this, what you're going to have is sodium chloride plus water, then plus CO2 gas, which is what? Giving off. Okay? So this particular one is also called neutralization reaction, but it is a reaction between an acid and a carbonate. A carbonate. Okay? This is a carbonate. The carbonate and acid will liberate salt, water, and carbon dioxide. Carbon dioxide. Carbon dioxide. So that is the product of the reaction. So these reactions are classified as neutralization reaction because salt and water is formed. The next reaction we'll talk about today is combustion reaction. Whenever you hear the word combustion, it means we are burning something in the presence of what? Oxygen. Combustion simply means burning in the presence of what? Oxygen. Okay, for example, when you react a hydrocarbon, when you burn a hydrocarbon in the presence of oxygen in excess, we are going to produce carbon dioxide and what? Water. So if it's a hydrocarbon we are trying to burn, if we are trying to burn a hydrocarbon or undergoing a combustion reaction of a hydrocarbon, it simply means that we are treating a hydrocarbon, we are reacting a hydrocarbon in the presence of air, which contains oxygen, right? To produce what? CO2 plus water. Plus water. So this reaction is a simple reaction, right? Reaction of a hydrocarbon plus oxygen to give us CO2 and water. Now, give me an example of any hydrocarbon you know. Okay? Example is methane. For example, when I react methane plus oxygen in excess, that is combustion reaction, I will get CO2 and water. So balancing the equation, you can balance the equation, right? Carbon is 1, carbon is 1. Hydrogen is 4. I'll put 2 here to balance it, right? So oxygen is 2 here. I have 2 plus 2 here, 4. So I have another 2 here. So it's balanced. Okay? Another example. Let's use any hydrocarbon. Let's say let's use C6H14. Let's use hexane, right? Hexane plus oxygen will give us CO2. No matter the hydrocarbon, so far as the combustion is a complete combustion. Complete combustion. So far as the combustion is a complete combustion, the product is CO2 and water. For incomplete combustion, what is produced is not CO2. Carbon monoxide is produced. Carbon monoxide is produced for incomplete combustion. But for complete combustion, we have this. Okay? Balance the equation. We have 6 here. Hydrogen is 14. Put 7 here. So this is 6 times 2, 12. Plus 7 is 19. So we have 19 over 2 here, which is the balanced equation. So these are examples showing the combustion reaction. Now take note, it's not a must that it's always a hydrocarbon that combusts, okay? Other substances, ammonia can combust too to produce a product. So this is an example showing a combustion of reaction, a complete combustion of a hydrocarbon, which means reaction of a hydrocarbon with excess air or oxygen to produce CO2 and water.